Visualizing solid shapes. Observe the surface of the solid. It is a flat surface. The flat surface of the 3D shape or solid is called face. Observe the adjacent faces that are meeting at the line. This line or line segment is called edge. Observe the meeting point of two or more edges of 3D shape. They are called vertex. Look, here we have some models of 3D shapes. Among these 3D shapes, some of the 3D shapes are bounded by only polygons. Those are flat surfaces. Some of them are curved surfaces. The 3D shapes which are bounded by only polygons are called polyhedrons. These are not polyhedrons because these 3D shapes are having curved surfaces, not made up of polygons. We have different types of polyhedrons. Here all the polyhedrons are bounded by convex polygons. According to the concept of convex polygons, so these polyhedrons are called convex polyhedrons. Here these polyhedrons are made up of concave polygons. So these polyhedrons are not convex polyhedrons. We have another type of polyhedron which is regular polyhedron. According to this concept of regular polygons, a polyhedron is said to be regular if its faces are made up of regular polygons and the same number of faces meet at each vertex. Observe the two important members of polyhedron family around are prisms and pyramids. A solid whose top and bottom faces are identical and parallel to each other and lateral faces are rectangular is called a prism. Observe some models of the prism. Some examples for prism in daily life are glass prism, which we use in physics for color prediction, and nameplate. A solid whose base is polygon and the lateral faces are triangular and meet at the vertex. Observe some models of the pyramids. Examples for the pyramids are the Great Pyramid of Giza and the Pyramid of the Roof of the House. Prisms and pyramids are named according to the shapes of the base. If the base of the prism is triangle, it is named as triangular-based prism. We can easily call it triangular prism. Similarly, if the base of the pyramid is triangle, it is named as triangular-based pyramid or triangular pyramid. If the base of the prism is square, it is named as square-based prism. We can easily call it square prism. Similarly, if the base of the pyramid is square, it is named as square-based pyramid or square pyramid. Its base is pentagon. What is the name of this prism? Yes, pentagonal prism. Base of the pyramid is pentagon. What would be the name of this pyramid? Pentagonal pyramid. Observe the number of faces of a cuboid. 1, 2, 3, 4, 5, 6, The number of faces of cuboid are 6. Number of faces we denote with capital F. Observe the number of edges of a cuboid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of edges of a cuboid are 12. Number of edges denoted by E. Observe the number of vertices of a cuboid. 1, 2, 3, 4, 5, 6, 7, 8. The number of vertices of the cuboid is 8. We denote the number of vertices with the capital letter V. Let us observe the relation between number of faces, number of edges, and number of vertices. If we add the number of faces and number of vertices, we get 6 plus 8 equal to 14, and 12 plus 2 equal to 14. So, the sum of the number of faces and number of vertices equal to the sum of the number of edges and number 2. Let us observe whether this relation is applicable to other 3D solids or not. In a triangular prism, the sum of the number of faces, 5, and number of vertices, 6, equal to 11. The sum of number of edges, which is 9, and 2 equals to 11. Hence, the relation between them is F plus V is equal to E plus 2. Similarly, for other solids also the relation will be applicable. Hence, the relation between number of faces, number of edges, and number of vertices is F plus V is equal to E plus 2. This formula is called Euler's formula. Let us summarize what we have learned. 3D shapes which are bounded by only polygons are called polyhedrons. Convex, regular polyhedrons according to the concept of convex and regular polygons. Two important members of polyhedron family around are prisms and pyramids. Euler's formula F plus V is equal to E plus 2.